Our task today is to rationalize the denominator and simplify. Our variables here represent positive real numbers, so we need to simplify this expression. The first thing that I notice is this exponent on x is an improper fraction, so I'm going to rewrite the numerator as x to the 1 2/3. I'm also going to write my radical as an exponent. So how I do that is I have 2x squared to the 1/3 power. I can now rewrite my numerator as x times x to the 2/3 power. I know I can do this because I know my properties of multiplying exponents. See, the power on this x here is really a 1. So when I multiply these two values, I know I have to add these exponents. So that's how I separated this numerator over here. I can also, in one step, distribute this power to the 2 and distribute the 1/3 to the x squared. So I'm going to rewrite my denominator as 2 to the 1/3 power times x to the 2/3 power. Notice that this x to the 2/3 power is a factor of both the numerator and the denominator. So I can simply eliminate this from the expression. So I can rewrite my expression as x over 2 to the 1/3 power. Now I'm going to rewrite my denominator back into a radical. So I have x as the numerator, and I have the cubed root of 2 as the denominator. Now I have to eliminate this radical because in our task, we need to rationalize the denominator. That's what it means to rationalize a denominator. I need to get rid of this radical. I need to eliminate it from the denominator. So what I'm going to do is I'm going to multiply our expression by the cubed root of 4 over the cubed root of 4, which I'll explain later. So I can now rewrite this as x times the cubed root of 4 over the cubed root of 2 times the cubed root of 4. From what I know about multiplying radicals, I can multiply the 2 and the 4 to have my denominator be the cubed root of 8. And now I'm writing the numerator over. Now notice I used this cubed root of 4 in the beginning because I knew that this cubed root of 8 equals 2. So I wanted to make my denominator not be a radical. So I tried to multiply my denominator by something that would yield me the cubed root of 8 because I knew the cubed root of 8 would equal 2, which is not a radical number. So I can rewrite my expression again as x times the cubed root of 4 divided by 2. Notice that this is fully simplified and it's rationalized. So we are now done.